Here you can see what impacts would be there because of the solar flare, because of the solar storm, because of the large intense burst of releasing of energy. So because of the ionosphere, there will be a disturbance in radio communication. Obviously, the ionosphere will be the first which will be affected by this intense burst of energy or the solar you can say flare. So because the solar flare emit X-rays and ultraviolet radiation, so that is going to ionize the uppermost atmosphere, and as a result of this, the signal loss would be the disruption in high frequency and radio communication would be disrupted. Radio communication would be overall, and you might have seen this VHF, very high frequency, ultra high frequency. So all of these bands you might have seen in television, or you might have seen these bands in radios as well. So all of these will going to stop, all of these will going to disrupt as a result of this solar flare. Satellites, there will be a damage and malfunctioning of satellite, because satellite is comprised of electronics, sensors, and yes, the lifespan of satellite could be shortened because the penetration of high energy X-rays and UV rays will going to alter the functioning of satellites. GPS and navigation would also be affected. Like there could be a reduction in energy because of the intense energy burst, solar flare. So there could be a distortion in the GPS signal. There could be a reduction in the positioning accuracy. Power grids will be the power grids would be the one of the more significant factor which will going to affect the human immediately. So because of the geomagnetic storm, if there is a coronal mass ejection, this flare will result into CME. No need to worry, because in science you will get to know about this. Solar flare could lead to the coronal mass ejection if it is there. So there will be what? There will be induced electrical currents in power lines, and when we have induced electrical currents in power lines, that could cause transformer failures, blackouts, or voltage fluctuation. I told you, we have seen this thing in Canada in 1989. We have seen this in USA as well. Why we seen this thing in Canada? It's because its location is located near to the polar region. In some next slide you will get to know that it is the height of our troposphere, or with respect to the different layers of our earth, the height is less at the polar region. That's why the impact was first there, or let's say the impact was not observed on the other places of the world because of the varying height with respect to the location on the earth's surface, varying height of atmospheric layers. We could have a astronauts and aviation disturbance. There could be a radiation hazard, like there could be a high altitude flight crews if that is there, that are exposed to the high radiation level, and yes, there could be skin allergies and there could be skin diseases if there is a astronauts and aviation, want to say in this way regarding the impact. Aurora formation will be there. There will be brighter auroras in northern and southern hemisphere. When we have a charged particles, these charged particles will going to excite the atmospheric gases near the poles, and that's how there will be a spectacle. There will be a spectacular aurora, or let's say the bright sky will be there. And yes, we have a surface. Yes, there will be a denser lower atmosphere, which is actually providing the shield to the human and to the ecosystem. That will not directly affected by this radiation, but indirectly, yes, it might be. The behavior of certain species would be changed. Our behavior will also be changed, because to some extent this magnetic field used to control our life in our daily life. See, I don't know as far as the belief is concerned, but I would like to tell you one scientific reason, that when a person used to die, and when we took that person cremation ground, so we used to put the location of that person, I mean the head of that person would be towards north direction. The leg used to be there in the south direction. you might aware, I hope you might aware about the Earth magnetic field. Like we have a North Pole and we have a South Pole. So from the North Pole and South Pole we have what? The same magnetic lines, the electromagnetic radiation is there. And so what we can say, the person who is died, he used to put in this way. Head will be towards north and his legs be towards south. The reason is the net magnetism should be zero. I don't know like to what extent it is scientific or not, but yes, we used to observe this thing, and there might be some scientific logic behind this. As of now, might not be aware, but who knows, in future we could have some more insight on this. So like indirectly, if I want to say, so it's because of this solar flare we could have this set of indirect impacts which could be visible on our earth surface, or let's say on the living system. Our biological clock could be disturbed. Okay, so that is what all about solar flare and its impact, of how the solar flare is going to affect the earth surface. Now there is a one more subtopic. See, I hope you remember in the very beginning I told you that geography is comprised of small topics. In each and every topics we have so many small topics, and yes, you have to be aware with each small topics, and then you should have a proper interlinkages ability, that you can connect one concept with the another. Then you will have what a comprehensive uh, learning, and we are doing this in same way. I'm telling you that wherever which concept is required. Okay, this is the new one. This geomagnetic, or let's say this geomagnetism, is all new one. It's a new topic, completely new topic. Okay, it's a subtopic, I would say. It's a very small topic. Okay, but you should pay attention because questions are likely to be asked for you. What is a geomagnetism? Geo means earth, and when we have a earth's magnetic field, that will be termed as what? Geomagnetism. Geomagnetism is believed to be there on our earth's surface. It's because of the outer core. When it comes to our interior of earth, I hope you remember in our previous session we have discussed about the crust, mantle and core. Specifically with respect to the outer core, which is liquid in its state. So it is because of the outer core, it acts like a magnet, and its outer core is resulted into the development of the magnetic field around the earth's surface. Okay, so this is being termed as what? Geomagnetism, the earth's magnetism overall. We can earth's magnetism. Now this earth magnetic field is extended up to the height of 3200 kilometers beyond the atmosphere. See, magnetic field is different thing, atmosphere is different thing. You might amaze that when it comes the rocket launching station of India, almost rocket launching stations, not only India, with respect to the other continents and countries as well, they are mostly located near to the tropical latitudes. First thing. Second thing is, with respect to the India specifically, we have Thumba rocket launching station. Now that Thumba rocket launching station is lying on the magnetic equator. It is lying on magnetic equator. As it is lying on the magnetic equator, and if you launch one particular launch, if you launch rocket, or if you launch one spacecraft, so it's very easy to reduce the development of charge on that metallic surface on that rocket. See, I told you that as there is a magnetic field around the earth's surface, and if you rotate something in this magnetic field, what would happen? If you rotate something in this magnetic field, what would happen? The charge will be developed. Now the same charge would be developed with respect to the spacecraft, because they are the big bodies, they are the big metallic objects, you can say, and when they are moving through the magnetic field with respect to their almost perpendicular position, so there will be a development of what? Charge. And if we have that charge, if it will going to interact with the PC printed circuit board, or if it is going to interact with any critical sensor, so there will be what failure of the spacecraft. So in order to reduce this possibility, in order to reduce the development of charge on the spacecraft or rocket, we prefer location which is almost near to the magnetic equator. Magnetic equator, it is different. So when we launch from the magnetic equator, the overall net charge which could be generated on the outer surface of rocket would be very less. And if it is less, there will be less chances of failure. However, there are other arrangements which used to done. I hope you have seen some sort of railway tracks, and there is a proper grounding of that railway track. Why there is a grounding? Now you will say the overhead wire which is there, that might resulted into the you know releasing of current, and passenger might got a shock. Okay, there is one more reason, and that is one of the most phenomenal reason. The phenomenal reason is that electric train is what a metallic object, and that same electric train is moving in the magnetic field of our earth at a speed of 100 or more than that. At that speed there will be a development of charge on the outer surface of train. In order to reduce that charge, there is what grounding of railway track. Sometimes you will see the static charge when you are about to deboard or onboard a particular train, or if you touch the surface, you will see rarely you will see shock. And that shock is what? That shock is because of that charge which has been developed because of the motion of metallic object train in the magnetic field of our earth. The same magnetic field which is being developed by the outer core, the liquid core of our earth. Alright, so these are the application, and you have to work on application more rather than the theoretical or the conceptual ideas. Alright, so moving ahead, so solar winds is actually a shield. This this earth magnetic field is like a shield. It protects us from the solar flare, it protects us from solar wind. When we have an intense energy release from the sun surface, so that energy will be deviated. It's because of this magnetic field. So we have a what magnetic shield on our earth surface, or let's say surrounding our earth surface, which is actually protecting us from the rare solar event, from the rare solar weather disturbances. Okay, so we have almost this much height to what we have a what extension of magnetic field. Now this solar flare or the solar wind, they interact with the earth magnetic field, and when they will going to interact with the earth magnetic field, there will be a protection of what? Aurora borealis. We have a glowing of a sky, we have a lightning in the sky, and when if it is taking place in the northern hemisphere, that will be termed as what? Aurora borealis. And when we have a same thing in the southern hemisphere, that is what? Aurora australis. Australia is in the southern hemisphere. When we have a glowing of sky in Australia, that will be termed as aurora australis, that is in the southern hemisphere. See, this is our magnetic field. Here you can see in this image, so it is extended up to the 3200 kilometers because of the outer core. Remember, our magnetic axis is different as that of the real axis, as that of the imaginary axis. Three of these axes are different. Okay, in mapping I will tell you that we have a Queen's Island where we have what? This geographical north pole. Here you can see in this illustration that we have a solar flare, and yes, we have a solar winds, and they are about to impact Earth, and it is because of this magnetic shield. Here the magnetic shield, and here this magnetic